Despite the fact that the James Webb Space Telescope, JWST, has only been operational for a little over 2 years, it has already made remarkable progress, revealing its full potential in ways that will surprise you. Human ingenuity has created a telescope far more powerful than originally imagined. In fact, it may have just discovered life on a distant exoplanet. How powerful is the James Webb Space Telescope? And has it finally found evidence of life on a faraway planet? Prepare to find out. Launched in 2021, the JWST has been surveying the farthest reaches of the universe, looking for signs of activity beneath the surface and possibly even advanced alien civilizations. It has also been studying the atmospheres of nearby exoplanets, searching for gases that might indicate the presence of life or chemical signatures left behind by extraterrestrial civilizations. At first, researchers weren't sure if the JWST could achieve these major milestones. To test its capabilities, they decided to challenge the telescope by having it look for intelligent life on Earth, the only known planet to be habitable and home to life. In a recent study, scientists gathered a sample of Earth's atmosphere and deliberately distorted the data to make it appear as though the telescope was observing our planet from a great distance, mimicking the view from 40 light-years away, near the TRAPPIST-1 star system. They then used a computer model to adjust the JWST's sensor abilities and looked for specific technosignatures, such as nitrogen dioxide and chlorofluorocarbons, CFCs, along with biological markers like oxygen and methane, both of which are produced by life on Earth. The results were astonishing. The telescope was able to identify these key markers with incredible accuracy, suggesting that it could detect signs of intelligent life on planets up to 40 light-years away, and possibly even up to 50 light-years away. This groundbreaking finding raised the possibility that the JWST could uncover evidence of extraterrestrial life throughout the Milky Way. One of the most intriguing discoveries came from the exoplanet K2-18b, located approximately 120 light-years away. This planet is about 2 to 3 times the size of Earth and has a mass 8.6 times greater. K2-18b is considered a highly irradiated world, meaning it likely has a liquid water ocean on its surface and a thick hydrogen-rich atmosphere. During observations, the JWST detected carbon dioxide and methane in its atmosphere, which is remarkable in itself. But the truly fascinating discovery was the detection of dimethyl sulfide, DMS, a compound found on Earth as a byproduct of life. On Earth, DMS is often produced by phytoplankton in the oceans, a microscopic organism that mimics plants. The presence of DMS on K2-18b is especially intriguing, as it could indicate the presence of biological activity, potentially a biosignature of life. While this discovery is groundbreaking, it's important to note that the presence of DMS doesn't confirm the existence of life. Further observations are needed to verify whether large amounts of DMS exist on K2-18b. But the fact that such a biosignature could exist on another planet is a tantalizing possibility that could significantly alter our understanding of life beyond Earth. Scientists used to focus primarily on rocky planets when searching for signs of life, but now there's a shift towards studying hot worlds, planets with high surface temperatures, hydrogen-rich atmospheres, and the potential for liquid water. These planets are more promising for atmospheric studies because many of the exoplanets discovered so far are very different from Earth. Researchers aren't sure if DMS is present on K2-18b yet, but it opens up new possibilities in the search for alien life. The study of biosignatures is challenging for many reasons. For instance, oxygen, which is a key biomarker on Earth, can also be produced through non-biological processes like the breakdown of oxygen-containing minerals or chemical reactions involving oxygen-rich compounds. This complicates our ability to definitively associate biosignatures with life. As we continue our search, scientists are expanding the criteria for what constitutes a habitable planet. In the past, the focus was on planets with sizes similar to Earth. Then they added the concept of the habitable zone, the range of distances from a star where liquid water could exist. Now researchers are going much further, analyzing the chemical makeup of exoplanet atmospheres. Using a method known as atmospheric spectroscopy, the JWST can identify biosignatures in the atmospheres of distant worlds. This method is one of the most advanced techniques for studying exoplanets, and it's already helping to uncover new possibilities in the search for life. Even as technology advances, scientists are finding creative ways to look for biomarkers. One promising method involves studying the Archean period of Earth's history, which was home to some of the planet's earliest life forms, such as purple bacteria. These bacteria reflect light in unique ways, similar to the red edge phenomenon seen in plants on Earth. This characteristic could help researchers identify similar life forms on exoplanets by using specialized optical filters. The JWST has already made numerous exciting discoveries, but these are just the beginning. One of the most debated topics in astrophysics is the expansion of the universe. For many years, scientists believed that the universe's expansion would eventually slow down. However, it has been shown that the expansion is accelerating. If only normal matter were at play, this wouldn't make sense. This led scientists to propose the existence of dark matter and dark energy, two mysterious substances that dominate the universe. Dark matter makes up about 27% of the universe and helps hold galaxies together, while dark energy accounts for around 68% and is responsible for the accelerated expansion of the universe. By studying the movement of galaxies, scientists are able to estimate the amounts of these elusive substances. In conclusion, the James Webb Space Telescope is already proving to be an invaluable tool in the search for life beyond Earth. While the evidence for extraterrestrial life is still inconclusive, the discoveries made so far, such as the potential biosignature on K2-18b, show great promise for the future of space exploration. As the JWST continues its observations, it could revolutionize our understanding of the universe and our place within it. Researchers have made careful estimations of phenomena like infinite foundation radiation and the overall structure of the universe, allowing them to deduce the existence of certain cosmic entities, even if we can't see or directly interact with them. For years, astrophysicists have sought proof of dark matter and dark energy, but this search might have recently taken a turn. Atomic fusion is the process that powers stars, including our Sun, where lighter elements like hydrogen fuse to form heavier elements, primarily helium. The massive energy released in this process is what gives stars their brilliance and sustains them in the vast expanse of space. This energy is emitted as heat and light, but there's a possibility that dark matter, or more specifically, the energy generated through its self-annihilation, could provide an alternative energy source for stars. The James Webb Space Telescope, JWST, is now enabling us to explore some of the most distant regions of the universe through its advanced deep extragalactic survey, essentially allowing us to look into the past. The early universe was vastly different from what we observe today, with strange celestial objects, such as stars hundreds of times larger than those that form today. 4 stars identified as JADES GZ10, JADES GSC 111, JADES GSC 2, and JADES GSC 13, have been recognized as some of the most distant objects ever discovered. Of these, JADES GZ11 and JADES GSC 13 are believed to be theoretical dark stars, potentially powered by dark matter. These stars are not only incredibly bright, up to 1 billion times brighter than the Sun, but also massively large, millions of times more massive than the Sun. Astrophysicists hypothesize that these dark stars could have formed in regions rich in dark matter shortly after the Big Bang, when hydrogen and helium clouds collapsed to create the first stars. The superbalance theory in physics may help explain how these dark stars formed. If we imagine the early universe as a vast cosmic kitchen, the formation of dark stars could be seen as dark matter particles interacting in a way similar to how matter and antimatter annihilate each other, releasing energy that heats the surrounding hydrogen and helium clouds. This energy transfer could cause the clouds to heat up and dark stars to begin to form. Unlike stars powered by atomic fusion, these dark stars would not emit high-energy light and could remain cold for much longer, growing in size and brilliance. These dark stars would eventually have a surface temperature similar to the Sun's but could be billions of times brighter. They may have a radius spanning up to 10 galactic units, making them much larger than any ordinary star. These baby galaxies, or mini-coronas, formed 200 million years after the Big Bang and were mostly made of dark matter. Given that early stars were composed only of light elements like hydrogen and helium, without heavier elements, these unique conditions might explain why dark stars could have existed in the early universe. Our inability to detect them until now is due to technological limitations, but with the advent of the JWST, this could soon change. So, how did the JWST capture these distant objects? The telescope utilized gravitational lensing, a phenomenon in which light is bent by the gravitational field of a massive galaxy or cluster in front of a distant star or galaxy. This lensing amplifies and distorts the light, making distant objects appear brighter and magnifying their images, even though their actual distance remains the same. This effect allows the JWST to observe distant cosmic objects in greater detail, giving us a clearer view of objects like these dark stars, though it will take some time before we fully understand their nature. Previously, JADE's GZ10 and JADE's GSC13 were thought to be galaxies, but with further observations, 3 of these 4 objects might be theoretical dark stars. If confirmed, these findings could provide answers to key cosmic questions. The JWST has already detected an unexpectedly large number of distant galaxies that appear far too massive for their age, defying traditional cosmological models. If some of these objects turn out to be dark stars, the energy from dark matter interactions could have allowed them to grow rapidly, reaching enormous sizes at an early stage in the universe. This could help explain the existence of supermassive galaxies in the early universe. Additionally, the early universe's supermassive black holes, which appear too large to have formed from regular stars, could have originated from dark stars that later collapsed. The existence of dark stars would also serve as evidence of dark matter particles and demonstrate how these particles interact beyond just gravity. The JWST has also identified 2 other interesting stars, Mothra and Godzilla, through gravitational lensing. These stars, more than 10 billion light-years away, shine far brighter than expected. Mothra is a binary supergiant system with one star at around 5,000 Kelvin and the other at 125,000 times the Sun's brightness, while Godzilla is considered the most luminous star ever discovered. The brightness of these stars challenges conventional explanations, suggesting that they are likely influenced by a nearby object, possibly a black hole or a region dense with dark matter, perhaps even a dark matter-dominated dwarf galaxy. While we can't yet fully explain the strange phenomena observed, these discoveries provide further evidence for the existence of dark matter. However, more research is needed to solve these cosmic puzzles. In recent times, we've uncovered an incredible amount of fascinating discoveries, and the universe will undoubtedly continue to reveal more secrets. Before we conclude, we'd love to hear your thoughts. Do you think the James Webb Space Telescope will eventually discover proof of an extraterrestrial civilization? If so, how might it impact life on Earth? Share your thoughts in the comments section below. We appreciate you watching and stay tuned for more incredible revelations about the universe and our place in it.